Good morning, one and all. Myself, Dr. S. Kumar, working as Assistant Professor in Department of CSE Honors. Today, we will discuss about simplified DES algorithm. So, coming to the aim of this section, this aim is understand to the block cipher techniques to understand the difference between concepts of block cipher and stream cipher, demonstrate symmetric cipher model section, applying SDS algorithm to the plain text to generate ciphertext. In this section, we will discuss about the introduction, block cipher principles, DS algorithm standard, and some how we are going to implement SDS. This section will provide the overview of SDS and how to apply plain text onto the given input. Encryption data one block at a time, used a broad range of applications, these kind of applications, and the block size is 64 to 128 bits. Sometimes it will take 128 bits. Most of algorithms are based structured referred as the Feistel block cipher structure. So coming to the block cipher and stream cipher. Stream is nothing but flow of numbers. So this algorithm will take the input as ki, that means bit 1, bit 2, bit 3 and so on. It will take bit 16 for 16 iterations. Coming to this one, block cipher, it at a time based on the algorithm, it will take 64 to 128 bits at a time as the input, and whatever the input size you are going to take the input, that much of ciphertext it will produce. And coming to the, this is the 2-bit block cipher principle. So you are going to give the 2 bits as the plain text, and you will going to the generating 2 bits ciphertext and so on. 0 1 1 0 1 0 0 0 1 1 0 1. If suppose the ciphertext is 0 1, so what is the 0 1? Where you are getting 0 1 is here. So we are going to specify this is the output. Okay, so this one is 0 0, this one is 0 0. So you are getting 0 0 means here the value is 10 and 1 0, sorry. So this is the way how we are going to create the block cipher principles. Suppose if you take this diagram, totally we are having 16 bits. 16 bits are mapped with 16 different bits. Suppose if you take the first bit, it is mapped with 4. So first is nothing but 16 bit value, this is the one, and 4 is nothing but 0 1 0 0. So the table you are having like this. So the same concept you are going to get, you are getting the ciphertext as 0 1 0 0. What it means? 0 1 0 0. What it means? This is this value. Okay, so this is the scenario how we are going to perform the encryption and decryption. Ideal block cipher. Here you are going to take the n bit input and maps to the 2 power n possible input states, and we are going to use substitution techniques to produce the 2 into n output states. Output states mapped into the n bit output. Ideal block cipher allows maximum number of possible encryption mappings from plain text block. Problems with the cipher, block cipher. So small block size is equivalent to the classical substitution techniques, so that we need to the large block size. Key must be the very large, because each and every session round we are going to use different keys. So in order to get the 64 bit size, we required 1021 bits of key size. So Feistel structure. So what is this Feistel structure? The Feistel structure is to perform the block ciphers. The Feistel structure proposed applying 2 or more ciphers in a sequence, so that result stronger than the component ciphers. N bit block length and k bit length 2k transformations rather than the 2 power n. Fiscal cybertext alternatives uses substitutions and transformations, and transformations is nothing but permutations, changing of the position from one position to another position, and it applies the concepts of diffusion and confusion. So the approach is plain text into splitted into two halves, sub keys, that means rounded keys are generated, and round function f applied on the right half, applying the substitution methods on the left half by using XNOR, applying the permutation, exchanging the values from swapping the values, implement XP net concept. So confusion and diffusion. Diffusion is nothing but statistical approach of plain text to reduce in the ciphertext. And for example, a plain text letter affects the value of many cipher letters, and confusion make the relationship between the ciphertext and key as the complex as possible. How? Apply complex nonlinear substitution algorithm. So coming to the SDS, the input size is 8 bit, the ciphertext size is also 8 bits, the key is 10 bit. Even though the plain text is 8 bits, you are going to use 10 bits. If the plain text is 64 bit, you need to use 1021 bit keys. All these keys are generated by using key generate algorithm with the help of 64 bit only. So that will be discussed in the SDS algorithm, DS algorithm, and number of rounds will be the 2, and rounded keys are generated by using the permutation and left shifts. Encryption algorithm uses initial permutation, round function, and switch offs. Decryption same as the encryption algorithm except the keys are modifying. So this is the structure of block diagram of SDS algorithm. So initially we are having IP and round function, swap, all these things comes under the R1 and R2, and this will be the initial permutation reverse. So suppose IP means what you are going to do is initial permutation. Permutation is nothing but exchanging of the keys from one position to another position. So suppose I am getting the input A, B, C, D. For our convenience I am going to take the English letters, but actually it is the bits. So first we are going to take B because this is comes under the second position, and sixth one F, the third one C, A, D, H, E, and G. So this is the thing we are having using IP inverse, and IP inverse is if what is the input it will get, the fourth position value. Suppose this is the input I am going to get, the fourth position value is the first, that means A, and first position is second, B, third position third, fifth position is the 4, fifth position that is D, and so on. So you will get the plain text as usual. So this is the initial permutation, it is the initial reverse permutation. So this is the key generation mechanism. So for 2 rounds, okay. So this is the detailed thing. 10 bit key is the input and P10, that means permutation 10, different values you are going to use, okay. So from 1 to 10, same thing, IP how we are going to apply, we are going to change the values. After that we are going to convert into 2 halves, first left, second left, and we are going to applying the circle left circular shift 2 times, and we are going to give the P8 box. What this P8 box will do is it will discard 2 values, okay. So if you are observe all these things, you are not able to find out 1 and 2 values, okay. So from 3 to 10 you will get the 8 values. This is the work done by the P8, and it will generate the 8 keys. After that, these 5 values are again given to the left shift 2 and left shift 2, 2 left shifts, and again it will give the 10 bit as the input and it will generate the 8 bit which is used for the round 2. And this is the in detailed thing. Here IP means we know about all these things we will discuss in the previous slide. And the EP, what it will do, it will double the input, it will accept the 4 bit and it will generates the 8 bit. That means it will write 2 times for each bit. If you are observe, 1 here, 1 here, okay. And what the P4 will do, by using X boxes we are going to convert 4 bits into 2 bits. How we will convert these things we will discuss in the next slide. After that, IP inverse, this is the one round, detailed round. So we are applying EP and P4 X boxes. This initial permutation and initial permutation inverse will be applied at the starting level and the ending level only. So how these X boxes are converted into 4 bits into 2 bits. Suppose we are going to have the 4 bit input. So 1010 is the input. I need to convert it into the 2 bit. If it is the S0 round 1, S0 box is used. So first and 4 bits are used to specify the row. First and 4 bits, that means 10. 10 means this is 00, 01, 10, 11, 00, 01, 10, 11. This row is highlighted and the column is 01, this one. That means this is the output. That is also 02, which is nothing but 2. So I am going to give the 4 inputs bits as the input and I will generate the 2 bits as the output. So in coming to the summary, SDS algorithm uses same functions for encryption and decryptions. The thing is, keys are different, okay. If the plain text is there, the first round it will use the first key, in second round it uses the second key. Coming to the decryption, the first round it will uses the K2 and the second round it will uses the K1. So security of SDS, 10 bit key gives the 1024 keys. Maybe with the huge computational power it maybe identify the brute force attack easily, okay. If you know the plain text and corresponding cyber text, it is very hard to identify the key. So what are the general characteristics? These are the self-assessment questions. What are the general characteristics of SDS algorithm? How is the key generated for SDS? What are the 2 rounds of encryption in SDS? What are the strengths and weaknesses of SDS? So these are all the terminal questions. What are the steps involved in encryption and decryption data with SDS? How is keys generated for SDS? So I am going to utilize these books for the reference. Thank you.